So in 8.1, we have the following steps, following information. First of all, check if sigma sub 1, which is the first population standard deviation. First population standard deviation. And sigma sub 2, the second population standard deviation are given. The second step is we have normal population and samples are independent from each other. We have a normal populations. We have normal populations. We are working with two populations. So let's write this guy here, normal populations, or if normality is not given to us, then we have the following. The first sample size is greater than or equals to 30, and second sample size is greater than or equals to 30. So this is your first sample size. And this is your second sample size. So now we have to check to see if samples are independent from each other or not. Samples are independent. Well, what do we mean by that? It means that samples selected from one population is not related to the samples selected from the second population. So, sample from the first population from population number 1 is not related to the sample from second population, population number 2. So samples are independent from each other. Step 4. What is null hypothesis? What is alternative hypothesis? So, how do we construct this? Again, we have 3 different categories. The first category is the mean of the first population is greater than or equal to the mean of the second population. So its complement, the mean of the first population is less than the mean of the second population. Less than, it means that we have a left-tailed graph. Or your null hypothesis says the mean of the first population is less than equals to mean of the second population. Its complement, mean of the first population, is greater than the mean of the second population. Or remember that we have a two-tailed test. The mean of the first population is equal to the mean of the second population. Its complement, they are not the same. The mean of the first population is different from the mean of the second population. So this is our fourth step. As before, define alpha or level of significance. After that, we need to find the critical values. Now find critical value or critical values. In the next step, we have to find standardized test statistic. Standardized test statistic, which in this case, it's follow this formula. Z is equal to x1 bar, the mean of the first sample, minus the mean of the second sample, minus the mean of the first population, minus the mean of the second population, divided by. Okay, on the denominator, we have the following. Square root of. It's a crazy looking formula. That's why we prefer to use a calculator. So on the denominator, you have sigma sub 1 squared over n1 plus sigma sub 2 squared divided by n2. And as usual, we check to see if z is inside the green region or rejection region. If it is, we reject the null hypothesis.
So why is different from the lectures? The 7, the standardized test statistic is different.
So if this standardized test statistic, if z is inside the green region, the green area, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. As I mentioned before, for chapter 8, we prefer to use our calculator. To use your calculator, okay, we go to stat, we go to tests. Now you have two populations. You need to find the two population Z test. Two sample Z test. Then we enter the information. If P is less than or equals to alpha, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. Information. And if P is less than or equals to alpha, we reject the null hypothesis. If P is greater than alpha, we fail to reject the null hypothesis. These are the steps. So let us go over one example together to feel more comfortable about hypothesis testing for two populations. Two sample z-test for the difference between the means. A credit card watchdog group claims that, okay, so this is our first keyword, claims. There is a difference there is a difference in the mean credit card debts of households in California and Illinois. Okay. The claim says they are not the same. They are different from each other. How do we interpret that? What's the meaning of there is a difference between these two means? They are not the same. They are not exactly the same. Very good. They are not equal to each other. So you write, hey, mu1 is not the same as mu sub 2. This is our alternative hypothesis. So we can quickly form our null hypothesis, which says, hey, the means are the same. Well, we're happy here. We actually constructed our null and alternative hypotheses. Well, let us move on. The results of a random survey of 250 households from each state are shown at the left. So 250. It means that our first sample size is 250. Our second sample size is also 250. Both of them are greater than equals to 30. For a sample of 250 households in California, well, the mean credit card debt is $4,777. So it's the mean of the first sample from the first population. So this is our first population. And this is our second population with the exact same sample size, 250, greater than equals to 30. The mean credit card debt of households in Illinois is $4,866. These are the important information that are given to us. Two populations. So this is population number 2, and this is population number 1. Well, what else is given to us? The two samples are independent from each other. Okay, they are independent from each other. And suppose sigma sub 1, the population standard deviation for California is $1,045. $1,045. And sigma sub 2, standard deviation for the second population in Illinois is also given to us, sigma sub 2, $1,350. Question says, do the results support the group's claim? What was the claim? There is a difference. So this is our claim. Do we see any difference? Okay. We have a hypothesis testing for two populations. What is our alpha? Alpha is 5%. So let us start. Since alpha is 5% and we have a two-tailed graph, we use inverse norm of 0.025 to find the critical values. So our critical values are negative 1.96 and positive 1.96. Let us take a look at our graph. Rejection region is divided into two equal pieces. One part is on the left, the other part is on the right, and the dividing numbers are negative 1.96 and positive 1.96. Now we have to move on to find the standardized test statistic, this crazy looking formula, and the outcome is negative 0.82. Is this number inside the rejection region, either to the left or to the right? This is negative 0.82. It's close to -1, and as you can see, it's outside the rejection region. So, based on the information that we have and the calculation that we did, we reject or fail to reject. Reject or fail to reject?
Fail to reject.
Fail to reject. Very good. We fail to reject the null hypothesis. It means that we can say that we support the null hypothesis. We support that they are the same. So there is not enough evidence that at 5% level of significance to support the group's claim that there is a difference in the mean credit card debts of households in California and Illinois. So based on the information that we have, based on the samples that we have, at 5% level of significance, we cannot support the claim of the group that they are different from each other. Excellent, Vijay. If we don't have sigma 1 and sigma 2, we have to use t-test. Very well. Excellent. So let us use our calculator to find the values that we need. So turn on your calculator, go to stat, go to tests. So the first one is z-test, the second one is t-test, but we're not using one sample. We have to look for two. Two refers to two populations. You're taking two samples. Since sigma is given to us, we have two sample z-test. So two sample z-test. Let's click on that. We don't have the actual data. What do we have? We have information about our samples. So we're going to select stats. What is sigma sub 1? What is the first population standard deviation? Very well, 1045. What is sigma sub 2? The second population standard deviation. Excellent, 1350. Okay, what is x bar 1? So x1 bar, or the first population sample mean, is 4,777. What is N1? The first sample size, 250. Well, how about the second sample mean? X bar, and it's related to the second population. So this is 4,866. Well, what is N2? N2 is 250, the second sample size. Let's move on to next step. Now we need to identify the type of hypothesis testing that we have. Note that it says there is a difference. They are not equal to each other, not equal to. So the graph, the hypothesis testing depends on the alternative hypothesis. So it's going to be not equal to. Well, let's click on calculate. Here we go. I click 2 times. Okay, calculate. Here we go. So what do we have here? Our z is negative 0.82. Do you see that? We have the exact same z value, negative 0.82. And your p-value is 0.40. So 0.40 is actually greater than your alpha, of course. It means that we fail to reject the null hypothesis, the exact same result. So it doesn't matter if you use your null hypothesis, alternative hypothesis, and use the rejection region or use the calculator. The outcome are the same. So this is 8.1, and you have information about population standard deviation. In 8.2, we don't have information about population standard deviation. So as you guessed, as VJ wrote it in the chat, we're going to use t-test. But here we have 2 options. So 8.2. Okay. These are all the same. The first step is actually to find first sample standard deviation and second sample standard deviation. So you have S sub 1 or first sample standard deviation and S sub 2 or second sample standard deviation. Then we move on to the next step. The populations are normal, or N1 is greater than or equals to 30, N2 is greater than or equals to 30. After that, we have to check to see if we have independent samples or not. Well, in step 4, we form our null hypothesis, alternative hypothesis. In the next step, we find alpha or level of significance. Okay, then we need the degrees of freedom before we're finding the critical value or critical values. Since sigma 1, sigma 2 are not given to us, we need the degrees of freedom. Then we find the critical values, and then we move on to standardized test statistic, which is our T. Here we have two cases. So one case says, if you know that two populations have the same standard deviation, you have to follow one formula. If you don't know that the populations have the same standard deviation, you have to follow a second formula. So let me write this down for you here. If sigma sub 1 is equal to sigma sub 2, if sigma sub 1 is different from sigma sub 2. Okay. In this case, in the first case, if they are equal to each other, the degrees of freedom is N1 plus N2 minus 2. And if they are different from each other, the degrees of freedom is the smaller N1 minus 1, N2 minus 2. This is for your degrees of freedom. You find N1 minus 1, N2 minus 2, you select the smallest one, and for your standardized statistic, you get two different formulas. So in this case, your T is equal to x1 bar minus x2 bar minus mu sub 1 minus mu sub 2 divided by square root of, okay, here we go. Note that here we have the formula that says N1 minus 1 S1 squared plus N2 minus 1 S2 squared divided by N1 plus N2 minus 2 times square root of 1 over N1 plus 1 over N2. This ugly formula gives you the standardized test statistic if sigma 1 is equal to sigma 2. If they are different from each other, we have to follow different formula. Okay, the degrees of freedom is going to be smaller N1 minus 1, N2 minus 1, so this is 1. This is N2 minus 1. And the standardized test statistic, T, is equal to, so the numerators are the same, x1 bar minus x2 bar minus mu1 minus mu2 divided by, so here we get square root of s1 squared over n1 plus s2 squared over n2. So in this case, in the first case, we say that we have a pooled estimate of standard deviation. So this is called a pooled, so pooled estimate. Okay. Now let's go over one example to feel more comfortable about using these formulas. So we are on the last page of 8.1, 8.2 note. Let's read this first, see what information are given to us. Then we go over our calculator. So here you have a manufacturer that claims that, okay, here we go, claims. The first keyword is given to us, that the mean operating cost, the mean operating cost per mile of its sedans is less than, another keyword for us, less than that of its leading competitor. So less than, it means that we can quickly form our null alternative hypothesis. Less than, it doesn't have any equality next to it. It means that our alternative hypothesis is given. The mean cost mu1 is less than mu2. Your null hypothesis says, hey, mu1 is greater than or equals to mu2, and note that the alternative hypothesis in this special case is your claim. You conduct a study using 30 randomly selected sedans, so 30 from the manufacturer, so 30 randomly selected sedans from the manufacturer that claims that. So it means that from the first population, you're selecting 30 and form your first sample. So N1 is 30. And 32 from the leading competitor. So 32 is actually your N2, the second population sample size. The results are shown at the left, okay? At 5% level of significance, can you support the manufacturer claim that the mean cost is less than the mean cost of the leading competitor? Can you support the claim? Well, these are the information that we have here. From the first population, I'm using a different color for first population. We took a sample of 30. The mean of the first sample is 52 cents. The standard deviation is 5 cents. from the second population, we took a sample of 32. The mean of the second sample is 55 cents. And the standard deviation of the sample, second sample, is 7 cents. We don't have sigma. Guys, be careful. We don't have sigma 1. We don't have sigma 2. It's not Z. It's not Z. We have the sample standard deviation, so it is T. Note that sigma 1 and sigma 2, the population standard deviations are not given. The samples are random and independent from each other. Why they are independent? Because you took the first sample from the first population, you took the second sample from the second population. They have nothing to do with each other. Like taking a sample from Toyota, taking a sample from Honda. Two different sets of samples. They have nothing to do with each other. They're independent. And both N1 and N2 are at least greater than or equal to 30. So now we have to use t-test. But before using the t-test, we need to construct our null hypothesis, alternative hypothesis that we already did. Well, okay. So which formula are we going to use? Take a look at the board. Are we going to use degree of freedom, N1 plus N2 minus 2, or we're going to use the degrees of freedom, N1 minus 1, the smaller, N2 minus 1? Which one? Are we going to use the first T, or are we going to use the second T? That depends. Do we have information about standard deviations of the population in the question? Do we have anything about that? If they are equal to each other, we're going to use a pooled estimate. If not, we're going to follow the second formula. So let us get back to the note. Take a look at the last line in the example. It says, assume the population variances are equal to each other. They are equal to each other. It means that we are using a pooled estimate. So, degrees of freedom is N1 plus N2 minus 2, which is 60. That's how we find the degrees of freedom. Remember that.
Question about
Remember that. Then we are using our t-table. On the left-hand side of our t-table, we have the degrees of freedom. So we need to be able to find the degrees of freedom. Since population variances are equal to each other, we're going to use a pooled estimate. Pooled estimate, it means that the degrees of freedom is N1 plus N2 minus 2, which is 30, plus 32 minus 2, or 60. So the degrees of freedom is 60. Our alpha is equal to 5%. And by using our t-table, we can find the critical value, t sub 0. So our critical value, t sub 0, is negative 1.671. And we have a left-tailed a left-tailed graph. It means that the rejection region or the green region is on the left-hand side. Now we have to move on to find our standardized test statistic, T. As you can see, your denominator as pooled estimate follows the multiplication of two radicals. If you get back to the board, they calculated the denominator first, then they find the difference between two means divided by that denominator. So this is our denominator. A lot of confusing calculations. That's why we want to use a calculator. Makes life much more easier. So T, or standardized test statistic, is negative 1.930. Is this inside the green region? Take a look at your green region. The dividing number, the critical value, is negative 1.671. And the standardized test statistic is inside the rejection region, negative 1.930. And you say that since T is in the green area, we reject the null hypothesis. We reject the null hypothesis. Am I right? It means that unofficially we support the claim. There is enough evidence at 5% level of significance to support the manufacturer's claim that the mean operating cost per mile of its sedans is less than that of its competitors. So let us use our calculator. Well, when we read our example, we need to take note. These are important information that we have. And we need to know if we are using a pooled estimate or not. Otherwise, our calculations are going to be wrong. So we have to go to stat, of course. Then we go to tests. Okay, let's turn on the calculator. Go to stat, go to tests. So again, z-test is for one population. T-test is for one population. The third option is two sample z-test. It's not a z-test. Why is that? Because we don't have sigma 1 and sigma 2. We don't have standard deviation of the populations. So it's not going to be two sample z-test. It's going to be two sample t-test. Click on that. We don't have the actual data. What do we have? We have information about two samples. So stats. Well, what is x1 bar? It is 0.52. What is the first sample standard deviation? It is 0.05. What is N1? N1 is 30. Okay, second sample. X2 bar is 0.55. Standard deviation of the second sample, 0.07. N2 is 32. Okay. Remember that your mu1 is less than mu2. So less than mu2, the middle one. Next, okay, is this pooled or it's not pooled? Pooled or not pooled? Which one? Which case is this?
Pool.
Pooled, very good. So it is pooled. Yes, and calculate. As you can see, our critical value, negative 1.671. Our standardized statistic, negative 1.930. Did the calculation for us here. P-value is 0.029. In the best case scenario is 3%. So P-value, let me write this here for you. P is roughly 3%. Your alpha is given as 5%, which is less than equals to alpha or 5%. So it means that you reject the null hypothesis. Do we have the exact same analysis here? Of course. We rejected the null hypothesis. Why? Because T is inside the rejection or green region. So it doesn't matter if you're using a calculator or doing the calculation using the formula, the outcome, the result must be the same.